So, okay, children, we'll go for the next concept, that is equations of a body which is projected vertically upwards. Now, till today we have studied about the body when it is moving downwards. What are the equations of motion? Okay, so equations of a body when it is freely falling. You have studied earlier. So now instead of freely falling, what do you have to do? If it is thrown upwards in upward direction, what will be the equations of motion? Okay. So, equations of motion when a body projected vertically upwards. When a body projected vertically upwards. Is it clear? So, earlier we are studying about the equation when the body is projecting downwards. Okay, that is nothing but freely falling we have studied. Now, when it is thrown upwards. So here what you have to assume is that whenever a body is thrown upwards, the direction of acceleration will be like this. So you have to take it as minus. Since the body is going away from the center of the earth, we have to take the acceleration due to gravity as minus. First thing you have to remove. Okay. First thing you have to remind. Now, we are having 4 different equations. The first one is that V is equal to U plus AT. Second one is that S is equal to UT plus half AT square. And third one is that V square minus U square is equal to 2AS. Fourth one, distance travelled in n second is equal to U plus A by 2 into 2n minus 1. So, this is what general equations we are having initially. Now, what you have to do is that whenever a body thrown upwards, its acceleration is due to gravity is taken as minus g, not plus g. So, this is one change you have to do. And for a freely falling body, you have taken the initial velocity as 0. Whereas, here you are not taking 0, you have to take it as u only, because you are throwing it from the down. When you are throwing it like this, you are applying velocity, right? You are applying initial velocity. So, why should you take 0? Is it clear? For a freely falling, you are leaving like this. So, initial velocity is 0. But now, you are throwing it in upward direction. So, you are applying a velocity. Clear? It's not 0. So, let us see how the equations changes for a body projected vertical upwards. So, the equation number 1, V is equal to, okay, in place of U, U only. In place of A, you are writing minus G into T. Like this, you got equation number 1. And whereas here, S is equal to, in place of U, U. So, only UT minus half GT square. In this case, V square minus in place of U, already I told you it is U, is equal to 2. In case of A, you are writing it as minus G. Right? In case of S, S is okay. Or if you are interested, let us assume that distance travelled is H. So, H. Then here also you could write S or H. No problem. H or S. Now, in this equation, distance travelled in nth second is equal to U. Whereas in case of A, it is nothing but minus G. G by 2 into 2n minus 1. So, like this we are changing equations, okay. By further simplification, you could write this as V square minus U square is equal to minus 2GH. Minus 2GH. So, these are the 4 equations of motion when a body is projected vertically upwards. These are the 4 equations of motion when a body, okay, let me say this is a body, it has been thrown in upward direction, it goes up like this. Okay, so when it is thrown in upward direction, we have to say that its velocity, initial velocity is u only. If we assume that this is point A, so velocity at point A is u. Since it is going in upward direction, I have to take the acceleration as minus g by saying that its direction is in upwards. Clear? So by taking these two possibilities, we could change the equations and we could get these final equations for a body projected vertically upwards. Is it clear? So now we'll go for the next topic. I hope it is clear.